for you to do. Maybe you already did it, but I want to get on to the next. The answer is 220, by the way, if you just want to write it down as you're practicing. We're going to go into simplifying expressions. So tomorrow we'll do equations, today we'll do expressions. When you have factorials, right, so simplifying expressions is just you have variables involved. And we're going to try to cancel out certain expressions in our from the ones we're given. I would say this, just like before, I would suggest to expand the greater expression first. For example, n plus 5 factorial is greater than n plus 1 factorial, right? You would just think about it, whatever n is, if you add 5 to n, then you obviously have a bigger number than if you add 1 to it. So n plus 5 is the one that would be greater. I just make sure you understand, because sometimes students are confused, right? N minus 4, right? Obviously n plus 5 would still be greater, and so forth. So you can have a variety of expressions. Just look at which one would make sense to be the greater. Between these two folks, where my fingers are, which one of these two is greater? N minus 4. Because you subtract less from n, obviously this is greater. Okay, so keep that in mind. There's certain values for which the expression is invalid. Okay, so these restrictions need to be stated. I will usually ask you state any restrictions. If you have multiple values, the largest one is the one that I want you to state for sure. And if that doesn't make sense to you, just hold on a bit. I will simplify the following. State any restrictions. Assume that n is part of the integer numbers. Okay, n only integers work for n, no decimals. That's what that is saying. So if you had something like this, and I asked you to simplify that, I don't know if you see it, but n plus 5 doesn't have a factorial on it, so we'll just leave it. But n plus 4 has a factorial on it. So that would be what? That would mean I would go n plus 4. What's 1 less than n plus 4? N plus 3. N plus 2. ... That would just continue on. And I'll just slap a factorial on it because it keeps going. So this is what we had before. This is what we got from n plus 4 factorial. But we slapped the n plus 5 in front of it. What does that mean? How can I rewrite that? I can really say, well, this is really just n plus 5 factorial at the end of the day, because I have one number that's slightly bigger than the one I had before. I will just give you an example here. Like if I told you 7 times 6 factorial, if I just give you that expression, wouldn't you just say, wait a minute, this is just 7 factorial, right? It is really just whatever that number in front of that 6 is, it's 7 factorial. That's the idea that I was using here. This is the more common scenario you're going to have, okay? Oh, I didn't do restriction. In this case, let's state the restriction. For this bracket right here, what can we not have for factorials? What can we not have inside the bracket for a factorial? Do you remember that? No negatives. You cannot not have any negatives. Okay? So in this case, n plus 4, what would we need for n to have 0? Because we could do 0 factorial. 0 factorial is just 1. N is equal to negative 4, right? So this is, you cannot have n is equal to negative 4 or less. Okay, you have to have it greater than that. So this is how we state the restriction overall. We say n has to be greater than or equal to -4 in this case. That is the restriction here for this expression. Okay. Let's do another one here. Let's do the restrictions first. The restrictions on top, I don't want to do it here because it's going to take up space. Let's do it down here. Restrictions. Top, for the n factorial, n would have to be greater than or equal to 0. Okay. The n has to be 0 or greater for this to be valid. What about the bottom? N would have to be greater than or equal to 2. Because if you have exactly 2, this turns to 0. That's all right. But it has to be greater than or equal to 2. You cannot have it less than that. So this is just ensuring that. Out of these two, which one is the greater number for the restriction? It is this one. So technically, this is what we call the overall restriction. That's annoying, right? Overall restriction. By the way, if you give me both, you're fine. But technically, this is the only one we need to state. This is going to take care to make sure nothing is going to be less than 2 anyway. So why would we state the 0 here, right? This is already taking care of it. Let's simplify this one now. Out of these two expressions, which one is greater? This one or this one? Hey, tell me to stop. I'm just kidding. This one is the greater one. N is greater. Because n minus 2 obviously would be the smaller factorial we would get. So we expand this one. N factorial is greater. Is the greater expression. So I go n multiplied. What is 1 smaller than n? N minus 1. What's 1 smaller than that even? N minus 2. Should I continue or should I stop here? Stop, just like before, right? And in the denominator, we have n minus 2, also factorial. Make sure you have a factorial for both of them, because if it's just n minus 2 in the denominator, it'd be a different story. So we get to cancel this out. So we are left with n times n minus 1. And you FOIL it. You remember distribute. You distribute it like this. So that would be n times n is n squared. N times -1 is just -n. Now you're done. Okay. This would be your simplified expression. And of course, you need to practice a few, and then you would figure it out. Let's keep going. Restrictions first, okay? Don't forget about them. Top, what's our restriction at the top? If you struggle with this, do this. Set up an equation where whatever is in there is equal to 0, and then you just bring the 2 over to the other side, and it's equal to -2. Okay? And then you have to state that n has to be greater than or equal to -2. Because once you figure out what turns the top 0, and we figured out that it's -2, then you need to make sure that all values of n are greater than -2. You just need to make sure you do that. Okay? Bottom. n minus 1 is equal to 0. You bring this one over. What happens to a number when you bring it over the equal sign? It changes signs, right? So you realize that n is equal to 1 is going to turn this thing into 0. So you state that therefore n would have to be greater than or equal to 1. Which one of these two is the greater number? Between negative 2 and 1, 1 is obviously greater. This is the overall restriction. If you have this one stated, you take care of everything else. You don't have any issues anymore. Okay? After a while, you won't need to do this. You'll just look at it. It's like, oh, if n is equal to negative 2, this is 0. So n has to be greater than or equal to negative 2. What about here? If n is equal to 1, this turns 0. So I got to make sure n is greater than or equal to 1. So that's how you approach it. You don't have to do this every time. Okay, let's break this down. Simplify it. Which one is the greater of expression? N plus 2, right? So we start with it. Don't forget, n plus 2. Whatever is inside, that comes first. And then there's one less than that. That would be what? N plus 1. And then one less than that would be n. And then one less than that, n minus 1. So you basically have to see that it's dropping by 1 unit every time. And I will stop there because I see an n minus 1 factorial in the denominator. And now you get to cancel it out. So you basically want to get rid of the factorial. That's basically what the end goal is here. But what about the very first one, Mr. Dirksen? The n plus 5 factorial, right? I just wanted you to get into a mindset. Usually it's like this. It's a fraction. And you want to simplify it. Okay. Oof, this one is ugly, right? It is ugly. You'll never get a cubic. This is a cubic. So I'll just leave it like that, I think. If you get it to the point where you get rid of the factorials, and yes, I want you to distribute if possible. You know what? I feel like it's gonna bite me if I don't do it. So I'm gonna do the distribution here. So what I will do is I will FOIL these out. So you gotta be careful. N times n is n squared. N times 1 is just 1n. 2 times n is 2n. 2 times 1 is just 2. What about that n outside? Don't worry about it just yet. Okay? We're going to clean this up first. This would be n squared. N and 2n, that adds up to 3n plus 2. And now this n that was outside is going to multiply in there as well. So n times n squared is n to the power of 3, right, cube, plus n times 3n is 3n squared. N times 2 is just 2n. So this is technically it completely distributed. Not very often that you're going to see this, but be prepared for it. Okay. Let's do this one here. And that'll be it. Then I'll let you work on some. Maybe I'll just start this one and let you finish this. Which one? Let's do the restrictions. You've got n minus 2 is equal to 0 on the top, right? So if the 2 comes over, n is equal to 2. So 2 makes the top 0. So you got to go n is greater than or equal to 2. What makes the bottom 0? Negative 1, right? So n has to be greater than or equal to negative 1. And out of these two, this is the greater number, right? So if n stays above 2, then I don't even have to worry about it going down to -1, so I don't even have to state this really. Which one is the greater expression here? n-2 or n+1? n+1 is greater, correct? Uh-oh. What does that mean? Watch. I'm going to break the bottom down this time. So n+1, right, itself first. And then one smaller than that would be n. Don't forget about it. One less than that would be n-1. One less than that would be n-2. And then you slap a factorial on it. Why am I stopping? Well, I hope you notice there's an n-2 at the top. Okay. So you just cancel this out with this one. $1,000,000 question. What am I left with in the numerator? What number? Yeah, there's 1 left. So don't be putting zeros or anything like that, or miraculously bring this up, right? Whatever's in the denominator, keep it there. Good practice is to FOIL this out. So maybe I'll let you do that for the rest of today's class, and then you try the one that's underneath it as well. And I'm going to ask you to take home an AC after, like, for homework, or if you want to get it started here, that's up to you. Finish this one. Please do the one that's underneath it. Tomorrow we're going to do equations. Okay, so I need you to be comfortable with this. And plus the take-home AC. So homework, page 15, plus take-home AC. This one has a very basic pathways at the back. So the one AC that I'm telling you about is actually 2. Some pathways here. Okay, I know you're gonna love it. I know. Just finish this one. I'll post the key.